guys, welcome back. In this video I'm going to talk about simplifying surds. Let's first look at the definition of a surd. If a is a positive integer which is not a perfect square, then square root a is called a surd. Let's look at the basic rules for square roots that we learned in year 8. Review. I believe you all remember this. Square root a squared equals to a. Square root a squared equals to a. Square root a times square root b equals to square root ab. Square root a divided by square root b equals to square root a over b. I believe you all remember these rules, so let's do some practice questions. Question A, square root 6 squared. We remember that square root a squared equals to a, so square root 6 squared basically equals to 6. Okay, question B, square root 15 divided by square root 3. As we know from the rule, square root a divided by square root b equals to square root a over b. So we can write this as square root a divided by b, so 15 over 3. And we can simplify 15 over 3 as 5. Okay, question C. 9 square root 2 times 4. As we know that 9 square root 2 is the same as 9 times square root 2. So we just need to times 9 by 4, which equals to 36 times square root 2. Okay, now let's consider the surd square root 12. We can factor out the perfect squared 4 from 12, which can be written as square root 4 times 3, which equals to square root 4 times square root 3 by using the rule conversely. And then we can simplify this as 2 times square root 3 equals to 2 square root 3. Hence, we know that square root 12 equals to 2 square root 3. And we will regard 2 square root 3 as a simpler form than square root 12 since the number under the square root sign is smaller. So, to simplify a surd, we write it so that the number under the square root sign has no factors that are perfect squares other than 1. For example, square root 18 equals to square root 9 times square root 2 equals to 3 square root 2. So no factors that are perfect squares. Okay, let me give you more examples. Example A, simplify square root 108. So we first need to identify the perfect squares in 108. We know that 108 equals to 2 times 2 times 3 times 3 times 3. Now let's find the perfect squares. This is the perfect squares and this is the perfect square. So we can extract 4 and 9 from 108. So we can write this as 9 times 4 times 3 equals to which equals to square root 9 is 3, square root 4 is 2 times square root 3 equals to 6 square root 3. That's the answer. Now let's look at this question. Expressed as the square root of a whole number. So we just need to put the 5 back under the square root. We can write 5 as square root 25 times square root 3. And we use this rule conversely, which will lead us to square root 25 times 3, which we will get square root 75. Okay, let me show you one question that includes Pythagoras theorem. Use Pythagoras theorem to find x, give the answer as a third. If you forgot the formula of Pythagoras theorem, it's a squared plus b squared equals to c squared. The sum of the squares of two short sides equals to the square of a long side. So in this diagram, we can see that x and 6 are the two short sides and 14 is the long side. So we can write a formula: x squared plus 6 squared equals to 14 squared. Then we simplify this formula. X squared equals to 14 squared minus 6 squared. X squared equals to 160. And x equals to square root 160. Square root 160 is the final answer, but it's not in the simplest form. We can express square root 160 as square root 16 times square root 10, which equals to 4 square root 10. Alright, that's all for today. I hope you enjoyed the video. Please subscribe and I will see you next time.